अस्सलाम वालेकुम दोस्तों, उम्मीद करती हूँ कि आप सब दोस्त खैरियत से होंगे। तो दोस्तों, आज की इस वीडियो में मैं आपके पास जो लेके आई हूँ रीडिंग, वो है फ़िज़िक्स की। तो इसका जो फ़िज़िक्स का हमारा चैप्टर हम देख लेते हैं। चैप्टर नंबर 13 है, इसका पास हमारे पास है करंट इलेक्ट्रिसिटी। तो इसकी ये देखिए, मैंने थर्ड पेज की इसकी आपको करके दिखाऊंगी। इसमें थोड़ी वर्डिंग डिफ़िकल्ट है, तो चलते हैं अपनी वीडियो की जानिब, अपनी रीडिंग स्टार्ट करते हैं। ये टॉपिक है हमारे पास ओहम्स लॉ। ठीक है, तो स्टार्ट करते हैं। We have seen that when a battery is connected across a conductor, an electric current begins to flow through it. How much current flows through the conductor when a certain potential difference is set up across its ends? The answer to this question was given by a German physicist, George Simon Ohm. He showed by elaborate experiments that the current through a metallic conductor is directly proportional to the potential difference across its ends. This fact is known as Ohm's law, which states that the current flowing through a conductor is directly proportional to the potential difference across its ends, provided the physical state such as temperature etc. of the conductor remains constant. Symbolically, Ohm's law can be written as V proportional to I, V is equal to Ri, where R, the constant of proportionality, is called the resistance of the conductor. The value of the resistance depends upon the nature, dimensions, and the physical state of the conductor. In fact, the resistance is a measure of the opposition to the motion of electrons due to their continuous bumping with the atoms of the electric. The unit of resistance is ohm. A conductor has a resistance of 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is applied across its ends. The symbol of ohm is micro. ये इसको माइक्रो बोलते हैं, ये हमारा इसका सिंबल है. If I is measured in amperes, V in volts, then R is measured in ohms. तो ये हमारा हो जाएगा. A sample of a conductor is said to obey Ohm's law if its resistance R remains constant, that is, the graph of its V versus I is exactly a straight line. A conductor which strictly obey Ohm's law is called ohmic. However, there are devices which do not obey Ohm's law. They are non-ohmic. The examples of non-ohmic devices are filament, bulbs, and semiconductor bodies. Let us apply a certain potential differences across the terminals of a filament lamp and measure the resulting current passing through it. If we repeat the measurement for different values of potential differences and draw a graph of voltage V versus current I, it will be seen that the graph is not a straight line. It means that a filament is a non-ohmic device. This deviation of IV graph from straight line is due to the increase in the resistance of the filament with temperature, a topic which is discussed in the next session. As the current passing through the filament is increased from 0, the graph is straight line in the initial stage because the change in the resistance of the filament with temperature due to small current is not applicable. As the current is further increased, the resistance of the filament continues to increase due to rise in its temperature. Another example of non-ohmic device is a semiconductor diode. The current voltage plot of such a diode is shown in figure. The graph is not a straight line, so semiconductor is also a non-ohmic device. नेक्स्ट पैरा हमारे पास है रिव्यू ऑफ सीरीज एंड पैरेलल कॉम्बिनेशंस ऑफ रेजिस्टर्स. In an electric circuit, usually a number of resistors are connected together. There are two arrangements in which resistors can be connected with each other. One is known as series arrangement and other is known as parallel arrangement. If the resistors are connected end to end such that the same current passes through all of them, they are said to be connected in series as shown in figure. Their equivalent resistance Re is given by R is equal to R1 plus R2 plus R3, so on. In parallel arrangement, a number of resistors are connected side by side with their ends joined together at two common points as shown in figure 13.10b. The equivalent resistance Re of this arrangement is given by 1 over Re is equal to 1 over R1 plus 1 over R2 प्लस 1 over R3 एंड सो ऑन. ठीक है, तो ये हमारी यहाँ से लेके यहाँ तक ओहम्स लॉ की हमने जो रीड उसका पैराग्राफ कर लिया है. और ये बहुत ही आसान थी. इसकी वर्डिंग एक दफ़ा आप इसको देखेंगे और आपको ये बहुत ईजी लगेगी. और उम्मीद है कि आपको मेरी ये वीडियो भी अच्छी लगी होगी। और अगर आपको हमारी वीडियो पसंद आई है तो आप इस चैनल को लाइक करें, सब्सक्राइब करें और बेल आइकन को ज़रूर प्रेस करें ताकि हमारी हर आने वाली नई वीडियो आप तक पहुँच सके। और नेक्स्ट वीडियो तक के लिए अल्लाह हाफिज़।